Hello, my dear friends. How are you all? I hope you all are good and fantastic. So, my dear friends, you are very welcome in our lecture number 4 of coordinate geometry. I hope, my dear friends, you will enjoy this lecture. So, without wasting the time, let's get started. Yes. So today we will discuss area of triangle. Okay. So in previous lectures we already learned about section formula and distance formula. Okay. So now in this lecture we are discussing about area of triangle, how to find the area of triangle. So first of all, what is triangle? So in geometry, a triangle is a three-sided polygon. What is? Yes, like this. And in previous chapter you already learned, okay, a triangle is a three-sided polygon. What? Yes, A, B, C. Okay, and which has three edges and three vertices. What is? Yes, which has three edges, means first, second and third. There are three edges, A, B, B, C, A, B, B, C, C, A, and there are three vertices. What? A, B and C. So in geometry this is a triangle. Okay, so now area of triangle is measured of the space covered by triangle in the two-dimensional plane. In the what? In the two-dimensional plane. Like this is a two-dimensional plane. Okay, so the area of triangle is measured of the space covered by the triangle. So I hope you understand this. So in this lecture we are going to be find the area of triangle. Okay, so my dear friends, there are different methods to find the area of triangle. So the first method is, okay, so the area of triangle can be found using different methods. So the method first is when we have a base and altitude of a triangle. Okay, when, let's suppose this is my triangle A, B and C. Let's suppose we have BC, means this is our base, and we have altitude. This is our altitude, means height. Okay, so we can find the area of triangle very easily. So area of triangle ABC, okay, which is A, which is equals to what? Base into height divided by 2, means BH upon 2. This is our base and this is our height, which is represented as H. Okay, and so our area is BH divided by 2 square unit. Okay, understand? I hope you understand this. I hope you get this point. So this is a method first, very easy method. Okay, now in case if we don't know the height, in case the height is not given, then what we can do? So there is a second method. So the second method is, so the area of triangle is calculating by, let's suppose we have a triangle A, B and C, and we have sides. This is A, this is B and this is C. Okay, now in this case we can find the area directly. How? So the formula is under root S into S minus A, S minus B and S minus C. Now I will tell you what is S. Okay, this is area. So now in this case we know that A, B and C, these are what? These are sides of triangle. These are the sides of triangles. and S is the perimeter, S is the semi-perimeter, S is semi-perimeter. What is S? S is semi-perimeter. So the value of S can be calculated as S is equals to A plus B plus C divided by 2. So this is the value of S. So from here we can find the value of S and we can put it in this equation. Okay. So my dear friends, I hope you understand this thing. So how we can calculate the area? Okay. So these two methods are only valid when we have the sides. Okay. Either we have sides or we have height. If we have length and if we have height and size, then we can find easily. Okay. So if we don't have any sides and height, so how we can find it? So there is a third method. Okay. So if the vertices of a triangle are given, if the vertices of a triangle are given, okay, then we can find the area. How? Let's see. Let's suppose we have again a triangle. Okay, this is A, B and C. Now let's suppose we have A is equals to x1, y1, and we have B is equals to x2, y2, and we have coordinate C is x3, y3. Okay, now my dear friend, with the help of these vertices, with the help of these coordinates A, B and C, we can find the area of triangle by the formula. And what is the formula? So the formula is A is equals to half into, okay, and here is x1 into y2 minus y3, okay, plus x2 into y3 minus y1 plus x3 into, okay, y1 minus y2. Okay, so this is the formula to find the area of triangle. Okay, with the help of this formula we can easily find the area of triangle. I hope you get this point, my dear friends. So here is, so this is very simple, very easy to remember this formula. It is looking like a very huge formula, but this is very simple, very easy formula. Like first of all, area is equals to half. This is simple. Now here you can learn it like 1 2 3 2 3 1 3 1 2. Okay, means x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. Okay, this is so simple formula, my dear friends. Okay, so in this method we can find the area of triangle with the help of vertices, okay, and what is the formula? So this is the formula. Okay, so I hope you understand these things, my dear friend. So now let's move on. So now let's see the proof of this formula. Okay, we have a Cartesian plane. This is our Cartesian plane. This is x, this is x dash, this is y, this is y dash. Okay, now we have a triangle and their vertices as, let's suppose we have a triangle like this. Okay, this is P, this is Q and this is our R. Okay, my dear friend. So now we have the vertices P is x1 comma y1 and Q is x2 comma y2 and R is x3 comma y3. Okay, so if we have a vertices of a triangle, now we are going to find this. You can find the area of this triangle. So from the point, with the help of point P, Q and R, we are going to draw a perpendicular line on the x-axis like this. So this is A, this is B, and this is what? This is C. Okay, I hope you understand this. Now there are three different trapezium are formed, such as like this. If you see that first trapezium is P Q A B, like this, P Q Q A B and AP, and second trapezium is P B B C C R R P. Okay, and third trapezium is Q A C R Q. Okay, so we have three trapezium. Okay, so for finding the area of triangle PQR, we have to find the area of these three trapezium. Okay, these three trapezium. So we have trapezium what? So there are three different trapezium form, such as PQAB, PBCR and QACR. Okay, in this plane. So now for finding the area of PQR, we have to find the area of these trapezium, and after finding the area of these trapezium, we have to add these two trapezium 1 and trapezium 2, and after adding the area of these two trapezium, we have to subtract the area of third trapezium from these two trapezium. Okay, so after that we can find the area of triangle PQR. Okay, I hope you understand these things. So now, so the area of triangle PQR can be calculated as area of trapezium PQAB plus area of trapezium PBCR minus, okay, area of trapezium PAQB plus area of trapezium PBCR minus, we have to subtract area of trapezium QACR. Okay, so with the help of this, we can find the area of triangle PQR. Okay, so yes, now step by step we are finding the area of these trapeziums. Okay, so firstly we are finding the area. So we are finding the first area trapezium of area of first trapezium, finding area of trapezium PQAB. Okay, so now we know that the formula to find the area of trapezium. So what is the area? So area of a trapezium is what? Half into sum of parallel side, sum of parallel side into distance between them, into what? Distance between them. Okay, I hope you understand these things. So now, so the area of trapezium is what? This is half into, now sum of parallel sides. Okay, so what are these parallel sides? If we see that the what is the which trapezium is? Trapezium is PQAB. Okay, and the parallel side is what? QA and PB, and the distance is what? AB. Distance is what? AB. So we are writing it here is half into sum of parallel side means QA plus PB, okay, multiply by AB, which is the distance between them. Okay, so now we have to find what is QA, what is PB, and what is AB. So QA is equals to, let's see in the figure. If we are talking about QA, what is QA? Q and A. Okay, so this is the distance between Q and A. So this is what? This is our Y2. Okay, and what is PB? So PB is this. So this is our Y1. Okay, and what is AB? AB is here, and this is what? X1 minus X2. X1 minus X2. Okay, so this is the distance of AB. So now we are putting here in this equation. So QA is what? QA is Y2, PB is Y1, and AB is X1 minus X2. Okay, now the area of trapezium trapezium is equals to half into OA we have Y2 plus PB we have Y1 into X1 minus X2. Okay, so this is our equation number 1. Okay, I hope you understand these things. So now finding area of trapezium PBCR. So now we are finding the trapezium. Now area of trapezium, what? Trapezium PBCR. So what is this? So half into PB plus CR into what? BC. Okay, so now what is PB? PB, we know that this is Y1. CR, this is Y3. BC is what? BC is X3 minus X1. What? X3 minus X1. Now putting this in this equation, so half into, it will become Y1 plus Y3, and this is X3 minus X1. So this is our equation 2nd. Now we have to find the area of trapezium, of QACR. Okay, which is equals to what? Half into QA plus CR multiply by AC. This is the area. So what is QA? Where is QA? QA is same Y2. QA is what? We have QA is Y2. Okay, CR. What is CR? CR, where is CR? Yes, here is CR is y3, and AC is, the distance AC is x3 minus x2. Okay, so now we are putting in this equation. So it will become half into QA, means y2 plus y3 multiplied by, this will become x3 minus x2. So this equation is equation number 3rd. Okay, my dear friends, now substitute these equation in our formula. So now, my dear friends, so area of triangle PQR will become, now here is, we know that area of trapezium PQAB plus area of trapezium PBCR, okay, minus, here we have to do the minus, which is equals to area of trapezium QACR. Okay, so now, my dear friends, put all these values. So we get, here is half into, this is y1 plus y2 into x1 minus x2, and area of trapezium PBCR, this is half into y1 plus y3 into what? x3 minus x1. Okay, now here is minus, and this will become half into y2 plus y3, and this is x3 minus x2. I hope, my dear friend, you understand these things. So now if we solve this, we get area of triangle PQR is equals to, we are taking half as a common, and after solving this we get x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Okay, I hope you get this point. So now, my dear friends, this is the formula of area of triangle. So, my dear friends, if we have the vertices of the triangle, then we can find, with the help of these vertices, with the help of these coordinates, we can easily find the area of triangles. I hope, my dear friends, you understand these things. So this is the proof of area of triangles formula. Okay, so now let's move on. Yes, there are some special cases. What? Let's see. If one of the vertices of a triangle is the origin, okay, then the area of triangle can be calculated as, so let's suppose we have a vertices of triangle is A is equals to 0, 0, B is equals to A, B, and C is equals to C, D. So the area is what? Half into 0 B minus D plus A D minus 0. So this will be plus C into 0 minus B. Okay, now if you solve this, we get, here is half into, so this term will become 0, and this is A into D, this is AD, and here is 0 minus B means minus B, and here is a sign of negative, and this is C into B. Okay, so we have the area is AD minus CB divided by 2. Okay, so this is the area. Okay, so this is the special case. Okay, I hope you understand these things. So now let's move on. Now let's talk about the collinearity condition. What is the condition of collinearity? If let's suppose we have 3 points. If we have point A, point B, and point C. Okay, and these points are collinear, and B lies between A and C, means that these points are collinear, and point B lies between point A and C. Okay, now we can say the first condition is this is always satisfy this condition. Okay, AB plus BC is equals to AC. If these points are collinear, then it is always satisfied. So AB, BC and AC can be calculated using the simple distance formula. Okay, so I hope you understand these things. And the second and most important condition is that the area of the triangle formed by three collinear points is 0. So the area of triangle formed by these points is always 0. Okay, so because these points are collinear. Okay, these points are what? Yes, these points are collinear. So we can say that the area of this triangle is always 0. Okay, so my dear friends, I hope you understand this concept. So now let's move on, and now we are going to solve some examples. Okay, so the first question is, find the area of the triangle whose vertices are this. So we have three vertices of a triangle of a triangle, and now we have to find the area by using these vertices. So let's suppose, so this is our x1, y1, this is x2, y2, this is x3, y3, and we know that area is equals to half into x1, y2 minus y3 plus x2, y3 minus y1 plus x3, y1 minus y2. So this is the formula. Now putting these values in this formula so that we can find the area, we can find the value of A. So half is equals half into x1 is what? We have 2, y2 is 0 minus 3 plus x2 is what? Minus 1, y3 is minus 4 minus y1 is 3. Okay, and here is y2 minus y3 means here is, this is what? Minus of minus 4. Okay, and now plus x3. What is x3? So we have x3 is 2, and we have y2 is 3, oh y1 is 3 minus y2 is 0. Okay, understand? Yes. So let's move on. Now let's solve this equation. Half into 2 minus minus plus, so 2 into 4 it will get 8. Okay, now if we are solving this, minus 4 minus 3 it will get minus 7, and minus 7 into multiply by minus 1 we get plus 7, so it is plus 7. 2 into 3 is what? 6 plus 6, so we have half into, okay, this is 14, 8 plus 6 is 14, 14 plus 7 is 21. So we get what? We get 21 upon 3. Sorry, 2. 21 upon 2. So we have area is what? 21 upon 2. This is our answer. Okay? Yeah. So let's move on to the next question. So the next question is, find the value of k for which the points are collinear. So here is the points are collinear. Okay, So in this case, what is the condition of collinearity? So the condition of collinearity is that the area of triangle is 0. So now this is our x1, y1, x2, y2, x3, y3. Okay, so now this area is half into x1, y2 minus y3 plus x2, y3 minus y1 plus x3, y1 minus y2. This is the formula. Now putting all these values, so half into x1 is what? 7 multiply y2 is what? 1 minus, we have minus k, so it will become plus k, plus x2 we have 5, y3 we have minus k, and minus 1 is y1 is minus 2, and it will become plus 2, plus x3 we have 3, and we have y1 we have minus 2, and minus y2 we have 1, which is equals to 0 because the area is 0. Okay, now we are solving this. So half into, this is 7 into 1 plus k, this is plus 5 into 2 minus k, this is, if we solve it, this is minus 3, and minus 3 into 3 minus 9, which is equals to 0. Okay, so now if we are solving this, if we shift 2 in the RHS, it will become 0. So we have 7 plus 7k plus 10 minus 5k minus 9, which is equals to 0. So now my dear friend, this will become 7k minus 5k, this is 2k. Okay, and here is 7 plus 10, which is 17. Okay, and 17 minus 9, which is plus 8, and this is equals to 0. Okay, and here is 2k is equals to minus 8, so we get k is equals to minus 4. So the value of k is minus 4. I hope, my dear friends, you understand this thing. Okay, so now let's move on. The next question is, find the area of the triangle formed by joining the midpoint of the sides of the triangle whose vertices are 0, minus 1, 2, 1, 0, 3. Find the ratio of this area to the area of the given triangle. Okay, now we have to find also the area ratio of this area of triangles. Okay, so let's do that. So first of all, we have to draw a triangle like this. So let's suppose we have a triangle. This is A, B and C, and the points are 0, minus 1, 2, 1 and 0, 3. And another triangle is formed from the midpoint of their sides. From the midpoint of their sides. So this is the midpoint of A and B, which named as D, and this name is E, and this named as F. So D, E, F are the midpoint of AB, BC and AC respectively. So now we can find the coordinate of D as, we can find the coordinate of dx is 0 plus 2 divided by 2, comma, minus 1 plus 1 divided by 2, and it will become 1, 0. This is midpoint by using the formula of midpoint. Okay, 1, 0. Now easily we can find the values, like this will become 2 plus 0 x1 plus x2 divided by 2, 0, 1 plus 3 divided by 2, and it will become 1, and it is 2. We can also find the coordinate of E as 0 plus 0 divided by 2, comma, minus 1 plus 3 divided by 2, and it will become 0 comma minus 0 comma minus 1. Oh sorry, plus 1. 0 comma plus 1. Okay, understand? So now let's move on. So now we are finding both the area of triangle. Area of both the triangle. Okay, yes. Yes, so the area of the triangle ABC. Okay, yes. Area of triangle ABC is what? Half into x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. So we are putting these values, so it will become half into 0 into 1 minus 3 plus 2 into 3 minus of minus 1. Okay, plus 0 into minus 1 minus 1, and if we solve it, it will become half into 8, and this will become 4 square unit. So the area of triangle ABC is equals to 4 square unit. And now we are finding the area of triangle DEF, which is what? Half into, if we put the values, if we put these values, it will become what? It will become 1 into 2 minus 1 plus 1 into 1 minus 0 plus 0 into 0 minus 2. Okay, so now this will become half into 1 plus 1. So this is 2 upon 2 and this is 1. So the area of triangle DEF is equals to 1 square unit. Okay, so we have the area of triangle DEF and area of triangle ABC. So the required ratio is, so the ratio is area of triangle DEF divided by area of triangle ABC, which is equals to 1 upon 4. This is our final answer. I hope you understand these things. So my dear friends, this is enough for today, and we will meet in the next lecture. Okay, so thank you very much guys for listening me. Okay, goodbye and take care.